Welcome to the next session. Now we start the session with classroom workbook of the concept maxima and minima. Let us start the session with question number 32. Consider the function f of x equal to 2x cube minus 3x square. 2x cube minus 3x square in the domain closed interval minus 1 comma 2. The local minimum of f of x is blank. So we need to find local minimum of f of x. It's a blank question. Here the domain is given as closed interval minus 1 comma 2. Domain is closed interval minus 1 comma 2. Now don't apply second derivative test because the domain is closed interval. So let us find stationary points f dash of x equal to 0. This implies the derivative is 6x square minus 6x equal to 0. This implies 6x into x minus 1 equal to 0. This implies x equal to 0 comma 1. Now both the stationary points belong to this interval, closed interval minus 1 comma 2. So calculate function value at these points as well as endpoints of this interval. F of 0. When you replace x by 0, the result is 0. F of 1. F of 1 is 2 minus 3. It is minus 1. F of minus 1. F of minus 1 is minus 2 minus 3. So this is minus 5. F of 2. 2 into 2 cube. 8 to 16 minus 3 into 4. This is 12 equal to 4. So what are my values? 0, minus 1, minus 5 and 4. Among those four numbers, 0, minus 1, minus 5, 4, minus 5 is minimum value. So therefore, its minimum value is minus 5, but they did not ask minus 5. They were asking at what point the function gets minimum, that is local minimum. So local minimum is minus 1. Okay, so here minimum value is minus 5. Therefore, local minimum is minus 1. Local minimum equal to minus 1. So in the blank, you write minus 1. Next, let us go through question number 33. If e power y equal to x power 1 by x, then y has maximum at x equal to e, minimum at x equal to e, maximum at x equal to e inverse and minimum at x equal to e inverse. So here what is my domain? Set of real numbers. So you need to follow second derivative test. Now let us find, because options were given in terms of e and e inverse. So we don't know which of these is a stationary point. So to get confirmation, let us find the stationary points at first. Apply log on both sides. Log e power y equal to log of x power 1 by x. Therefore, this y equal to 1 by x into log x. Now to get the stationary point, evaluate dy by dx and make this equal to 0. So here this dy by dx. Now this is product of two functions. Apply product rule. 1 by x into log x derivative 1 by x plus log x into 1 by x derivative minus 1 by x square equal to 0. This implies you can take 1 by x square common. 1 by x square into 1 minus log x equal to 0. Now here product of two numbers is 0. So 1 by x square into 1 minus log x is 0. Product of two numbers is 0 means any one of them must be 0. But there is no chance to get 1 by x square 0. 1 by x square is 0 when x is infinity. But stationary points must be finite numbers, not infinite numbers. Therefore, this 1 minus log x must be equal to 0. So therefore, 1 minus log x must be equal to 0. This implies log x equal to 1. Therefore, what is my x? It is e. Because here base value is v, so x equal to e power 1. So therefore, e power 1, x is equal to e is my stationary point. Now let us apply second derivative test. Actually here dy by dx equal to 1 by x square into 1 minus log x. So to get the status at the point E for the function y, let us find second derivative. So d square y by dx square equal to 1 by x square into derivative of this is minus 1 by x plus 1 minus log x into derivative of 1 by x square is minus 2 by x cube. So therefore this is minus 1 by x cube minus 2 by x cube plus 2 log x divided by x cube. Therefore this expression is minus 3 by x cube plus 2 log x divided by x cube. Now replace x by the stationary point. D square y by dx square at x equal to e is minus 3 by e cube plus 2 log e divided by e cube. Anyhow log e is 1 only because base value will be e. So therefore this is nothing but minus 1 by e cube. This is negative because e value is a positive, that is 2.71 Euler's constant. So d square y by dx square at a stationary point e is giving a negative value. Therefore by second derivative test this e is a local maximum. Therefore y has a maximum at x equal to e. Y has a maximum at the point x equal to e. So option A is right answer. Note these points. Now let us move to question number 34. A point on the curve is said to be an extremum if it is a local minimum or a local maximum. Already we had a discussion about local minimum and local maximum. So if it is either a local minimum or a local maximum, then this is called an extremum point. So definition is given. The number of distinct extrema for the curve 3x power 4 minus 16x cube plus 24x square plus 37 is blank. They were asking number of distinct extrema for the curve 3x power 4 minus 16x cube plus 24x square plus 37 is blank. So that means simply they were asking how many least stoppers and highest stoppers were there in this class. Always compare function with classroom. How many least stoppers are there? There can be more than one least stopper. There can be more than one highest stopper. So totally these points will be called as extremum points. When you look at classroom, they will be called as least stoppers and highest stoppers. Even they will be called as extremum points, topmost people. Least, very low cadre people, topmost people. Topmost people means in terms of percentage. Low means their performance is very, very low. So they will be called as extremum points. Let us see. Now let us see, let us find at first the stationary points of this function. Take the function equal to f of x. So stationary points means f dash of x equal to 0. So this is 12x cube minus 48x square plus 48x equal to 0. We can take 12x common, 12x into x square minus 4x plus 4 equal to 0. Now therefore this implies x into, this is what? X minus 2 whole square equal to 0. Therefore my stationary points are 0, 2, 2. So actually we have two distinct stationary points. It doesn't mean that they will be local minimum as well as local maximum. In the option 2 is there. So actually people may think that here we got two distinct stationary points. So they may go for 2. It's the wrong thing. So don't go for 2. There are two distinct stationary points. So we don't know those two stationary points lead to local maximum or local minimum. That we can't have any assurance. So just go for analyzation. So these are my extremum points. Let us calculate f double dash x to apply second derivative test. Therefore this is 36x square minus 96x plus 48. Now let us replace x by the first stationary point. F double dash of 0 is 48. Now this is greater than 0. Implies 0 is a local minimum by second order derivative test. 0 is a local minimum. Therefore, at this moment, we got one stationary point. Now, one stationary point, even that is also called as extremum point. Okay. So, we got one extremum point. Now, let us come to point number 2. So, that means f double dash of 2. So, replace x by 2. 36 into 2 square minus 96 into 2 plus 48. 36 fours 144 minus 192 plus 48. Now this quantity is 0. Now this is the drawback. Now second derivative at a stationary point is 0. That means the test fails. So test fails means we cannot conclude directly about this point 0. But we got 0 is a local minimum. So f double dash of 2 is 0. Therefore, we can't say about this point 2. 2 can be local minimum or a local maximum, or it can be both, or it can be none. Suppose if 2 is neither local minimum nor local maximum, then 2 cannot be called as extremum point. In that case, only 0 will be called as an extremum point. Then answer will be 1. That means in that case, we will have only one extremum point. They were asking count, but if 2 is either a local minimum or a local maximum, definitely that will be called as an extremum point. In that case, the number of distinct extremum points will be 2. Okay. Now, let us go for analyzation about the point 2. Here, 0 is a local minimum. Since 0 is a local minimum, what is its minimum value? F of 0. So, replace x by 0, you will get 37. So, min value is 37. Actually, this is not required for me, but here I am not getting any clarification about 2. That's why I calculated minimum value, that is 37. Now let us find the function value when x is 2. Calculate f of 2. F of 2 means 3 into 2 power 4 minus 16 into 2 cube plus 24 into 2 square plus 37. Now let us see, this is 3 16s 48, 16 8s, this is 128 plus 24 fours 96 plus 37. Therefore, the result here is 96 plus 37 plus 48. How much this is? 13, 21, 6, 15, 181. So this is 181 minus 128. So the result is, let me check out this once. 3 into 2 power 4 minus 16 into 2 cube plus 24 into 2 square plus 37. This is 16. 3 16 48. 2 cube 8. 16 8 128. 24 fours 96 plus 37. 48 plus 96 plus 37. So 13 plus 8 21. 6 plus 3 9. 9 plus 9 181. You subtract 121 from this. The result is, this is 3. This is 17. So the value is 53. Yes. So it is right value 53. Now here 53 is greater than 37. Therefore, this 2 is not a local minimum. So when you compare this value and this value, we can say that 2 is not a local minimum. Why 2 is not a local minimum? If 2 is a local minimum, then f of 2 must be 37. But f of 2 value is dominating 37, therefore 2 cannot be local minimum. That is very clear. Next, I must know confirmation about local maximum for 2. Even if I don't get local maximum for 2, then 2 cannot be called as an extremum point. In that case, I will have only one extremum point, so the answer will be 1. Now let us see f of 3. I will try to calculate the function value at 3. See, why I go for 3? Because what is the domain of this function? The domain of this function is R. So I go for evaluation of f of 3, f of 4 like this, unless or until I get some clarification about extremumness of the point 2. So f of 3 is 3 into 2 power 3 into 3 power 4 minus 16 into 3 cube plus 24 into 3 square plus 37. Now let us simplify this. So this is 3 into 3 power 4. 3 power 5 is 3 power 4 is 81. 81 3 is 243. 16 nines is 144. So subtract 144. This is minus 13 minus 4 13 9 this 23. This is 99. So in this case the value is 99 up to this moment. So this value is 99. This is plus 3 into 3 power 4 minus 16 into 3 cube. Sorry, here 3 cube is not this 3 cube is 27. So let me calculate once again. This expression is 243 minus 16 27s, 27 tens 270, 27 6 42. This is 12 plus 4 16. So 162. So this is 432. So 243 minus 432 plus 24 nines. 24 nines is 36 216. So 216 plus 37. Now add all these values. 243 plus 216 plus 37. This is 253. So therefore this is 496 minus 432. So subtract this, you will get 64. Therefore this f of 3 I am getting as 64. Now this is a crucial factor to say about the point 2. Let us see. Here what is my f of 2? The value of f of 2 is 53. So what is f of 3? 64. So I will write like this. So here the f of 0 is less than f of 2 less than f of 3. But what is f of 0? This is 37. This is minimum value. F of 3 is 64 and this value is 53. That means this fellow is the least topper of the class and least mark in the class is 37. Here 53. So inside this class the students are 0, 2, 3. So 0 is a local minimum and that fellow marks are 37. In the same class there is another roll number 3 because its domain is R. You can take f of 3, f of 4. So in the same class there is another student whose marks are 64. In the class there is one student whose mark is 53. So 53 is not a local minimum. So this fellow marks are dominating 37 and below 64. Therefore these marks are neither least marks or highest marks. Therefore 2 is not a local minimum as well as not a local maximum. But I am not saying that this 3 is local maximum. 3 can be anything. So this particular fellow, roll number 2 is having marks 53. Roll number 3 is having marks 64. Roll number 0 is having marks 37 and 0 is a local minimum. So least mark is 37. See, let me tell you one example. There are 3 students in a class. 3 students were there in a class ABC. Assume that this fellow is the least fellow whose mark is, for example, 41. So this fellow marks are, for example, 56. This fellow marks are, for example, 67. Now there is one student in the class whose marks are less than 56. In the same class there is another student C whose marks are greater than marks of B. Therefore this fellow is an average student, neither local minimum nor local maximum. Therefore because of this 2 is not an extremum point. So from this I can say that 2 is not a local maximum also. Therefore 2 is not a local minimum, 2 is not a local maximum. So 2 is not an extremum point. So therefore we have only one extremum point. So the answer is count 1. The result is 1. So it is option number B. Please note this. Now let us move to question number 35. the function f of x equal to, we were discussing question number 35. The function f of x equal to 2x cube minus 3x square minus 36x plus 2. 2x cube minus 3x square minus 36 plus 2 has its maxima at, so they were asking local maximums. Okay, now let us see what is the domain of this function, or because interval is not specified, so obviously you need to take domain as set of real numbers. The domain is set of real numbers. So find stationary points f dash of x equal to 0. This implies 6x square minus 6x minus 36 equal to 0. So we can take 6 common, x square minus x minus 6 equal to 0. Its factorization is x minus 3 into x plus 2 equal to 0. So the stationary points are 3 minus 2. Now let us find second derivative f double dash x equal to, this is 12x minus 6. Now replace x by 3, you will get 36 minus 6, 30. This is greater than 0. So 3 is a local minimum which is not required for us. 3 is a local minimum. But replace x by the second stationary point f double dash of minus 2. So this is 12 into minus 2, minus 24, minus 6, minus 30. This is greater than 0. Because of this greater than non-zero, I mean greater than, sorry, this value is less than 0. So therefore this minus 2 is a local maximum. Therefore f of x has its maximum only at x equal to minus 2. Only at x equal to minus 2. Because we got two stationary points 3 and minus 2. At 3 the function is getting minimum which is not required for us. But at x equal to minus 2, second derivative is becoming less than 0. So the function takes maximum only at x equal to minus 2. So option is A. It possesses maximum only at minus 2. The optimum value of the function f of x equal to x square minus 4x plus 2 is, options are given. Optimum values means they can be minimum or maximum. They can be minimum or maximum. Let us see. In option 2, maximum value is given. 2 is maximum, 2 is minimum, minus 2 is maximum, minus 2 is minimum. So therefore they refer to maximum and minimum values but not local maximum and local minimum. Right? Optimum value means if it is either a minimum or maximum. If it is either a local minimum or local maximum, it is called as extremum point. Please try to understand the difference between optimum value and extremum point. Extremum value means if it is either a local minimum or local maximum. Optimum value means it can be either a minimum value or maximum. Now let us find stationary point at first because the domain is R only. So here f dash of x equal to 2x minus 4. So therefore f dash of x will be 0 implies x equal to 2. So this is the stationary point. Now find second derivative f double dash of x is 2. Replace x by the stationary point, it is 2 positive. So therefore this 2 is a local minimum. This 2 is a local minimum. Therefore minimum value equal to f of 2. Minimum value equal to f of 2. Replace x by 2. So 4 minus 8 plus 2, this is minus 2. So generally people may confuse about this point. Here 2 is a local minimum. In option B, 2 minimum is there. 2 minimum. That is wrong answer. So, but in option D, you have -2 minimum. So, minimum value is -2. So, option D is right answer. We have a function f defined from closed interval -1 comma 1 to r. This is defined by f of x equal to 2x cube minus x power 4 minus 10. 2x cube minus x power 4 minus 10. They were asking minimum value of this function. Here, what is the domain? Domain is closed interval a comma b. So we should not apply second derivative test. But as usual, you find the stationary points. F dash of x equal to 0. So this implies 6x square minus 4x cube equal to 0. So you can take 2x square common. This is 3 minus 2x equal to 0. So therefore x into, or you can take 0 comma 3 by 2. So these are my stationary points, 0 and 3 by 2. But actually x equal to 0, this belongs to closed interval -1 comma 1. But the stationary point x equal to 3 by 2, 3 by 2 means 1.5. This does not belong to closed interval -1 comma 1. So ignore the second stationary point. So therefore this fellow is not a student of this class. So even though this fellow gets highest marks, we should not consider. Even though this fellow gets least mark, you should not consider that fellow, because this fellow is not a member of this class. Okay. So but 0 belongs to this. So calculate function value at the endpoints -1, 1 and at its stationary point 0. So what is f of -1? Replace x by -1. So you get as -13. Replace x by 1. F of 1. 2 minus 11. This is -9. Replace x by 0. You will get -10. So among these three numbers, this is the minimum value. So therefore the minimum value of f of x equal to -13. Minimum value of this function is -13, because among these three this is minimum. Hence this function is minimum value of this function in the entire domain closed interval -1 comma +1. So the answer is -13. Note this. Now with this, we have finished classroom workbook on maxima and minima in case of functions of single variable. Next, we discuss functions of two variables. Now here at first we start with the definition of stationary point. Suppose f of x comma y is a function in two variables over the domain R square. Domain is R square. Basically R square is nothing but set of ordered pairs a comma b such that a is a real number and even b is also a real number. So this is the domain of this function. Here we restrict functions of two variables to a single domain, that is R square. R square means R cross R. That means in the R cross R, the elements will be ordered pairs, two-dimensional points, two-dimensional plane. A is a real number, B is real number. Now let us see. We have a function f defined on domain R square and a comma b is a two-dimensional point. A comma b is a two-dimensional point. We say that this is a stationary point of this if dou f by dou x equal to 0 and dou f by dou y equal to 0 at this point a comma b. So that means all first ordered partial derivatives dou f by dou x, dou f by dou y will be 0 when you replace x by a and y by b. In the earlier, when we deal with functions of two single variable, We were calculating directly derivatives. So when f dash of a is 0, then a is called stationary point because function contains single variable. Now one variable has been introduced extra. Therefore, here f is depending on two variables x and y. Therefore, I cannot discuss ordinary derivatives. So let us evaluate partial derivatives. If dou f by dou x, that means to differentiate f with respect to x only. When you are differentiating f with respect to x, y is constant. Similarly, when you are differentiating f with respect to y, x is constant. So when dou f by dou x and dou f by dou y become 0 at the point a comma b, then this is called a stationary point of this function. Let me tell you one simple example. Suppose f of x comma y is x square plus y square. Now here find dou f by dou x. This is 2x. Dou f by dou y, this equal to 2y. This becomes 0 only when x is 0. It will be 0 only when y is 0. Therefore, 0 comma 0 belong to R square. This is a stationary point of this particular function, not this. A point a comma b belong to R square. Heading definition of stationary point. A point a comma b belong to R square. A point a comma b belongs to R square is said to be a stationary point of f of x comma y. Is said to be a stationary point of f of x comma y if dou f by dou x equal to 0 and dou f by dou y equal to 0 at a comma b. If dou f by dou x equal to 0 and dou f by dou y equal to 0 at a comma b. Example, f of x comma y equal to x square plus y square. Dou f by dou x equal to 2x. Dou f by dou y equal to 2y. Dou f by dou x equal to 2x. Dou f by dou y equal to 2y. Here dou f by dou x equal to 0 implies x equal to 0. Dou f by dou x equal to 0 implies x equal to 0. Next, dou f by dou y equal to 0 implies y equal to 0. Therefore, 0 comma 0 is a stationary point of f of x comma y. 0 0 is a stationary point of f of x comma y. You write this domain so that you can understand. In the R square, elements will be like this. Now let us discuss maxima and minima of functions of two variables using second order derivative test. So next one is second order derivative test, but in this case we were handling functions of two variables. Second order derivative test. Suppose we have a function f of x defined on R square. We need to find maximum values of f of x comma y and even minimum value of f of x comma y defined on R square. So it takes some 6 to 7 steps. Let us see. In first step, calculate all stationary points of f of x comma y. Calculate all stationary points of f of x comma y and assume that P is one of its stationary points. That is in case of single variable. Here assume that a comma b is one of its stationary points. One of its stationary point. See, this step is almost same as the step what we have seen in functions of single variable. Now step 2. Evaluate d of x comma y equal to fxx into fxy minus fxy whole square at the point a comma b. What is this fxx? This fxx is nothing but second order partial derivative of f with respect to x. What is this fxy? So this is fyy. fxx into fyy minus fxy whole square. So fxx equal to dou square f by dou x square. fyy equal to dou square f by dou y square. And this fxy equal to dou square f by dou x dou y. All second order partial derivatives. Evaluate this expression fxx into fyy minus fxy whole square. And in this expression, replace x by a and y by b. Step 3. If d of a comma b is positive and dou square f by dou x square at a comma b is positive. So d must be positive always. If dou square f by dou x square at a comma b is greater than 0, implies a comma b is a local minimum. A comma b is a local minimum. Because we have seen when second derivative at a stationary point is positive, this point is a local minimum. Now step 4. If d of a comma b is greater than 0 and dou square f by dou x square at a comma b is less than 0. Second derivative at a stationary point is less than 0, implies, what do you say about a comma b? This a comma b is a local maximum. Step 5. Suppose if d of a comma b is less than 0. Now when you observe step 4 and step 3, this is the condition to get an extremum point. So whenever d is greater than 0, then there is a chance to get local maximum or local minimum. But if d value is negative, implies this point is neither a local minimum nor a local maximum. So a comma b is neither a local minimum nor a local maximum. Now last step, if d of a comma b equal to 0, implies test fails. Test fails means the point behaves differently in different examples. But when you look at case 3, case 4, the condition to get an extremum point is d must be greater than 0. D of AB is greater than 0, D of AB is 0. When second derivative at a stationary point is less than 0, the point is local maximum. When second derivative at a stationary point is positive, it is local minimum. That means either in case 3 or in case 4, the common condition we have is d value is greater than 0. Unfortunately, if d is negative at a stationary point, then you need not worry about dou square f by dou x square, because when d is negative, that point is neither local minimum nor local maximum. If d is equal to 0 at the stationary point AB, the test fails. Okay. So test fails means it can be either a local minimum or a local maximum or both or none. Note down all these points.